Hey there, future scientists. Have you ever stopped and really thought about sound? It's everywhere. When your favorite cartoon character shouts, "Woohoo!" or when your pet dog barks a happy hello. Even when you munch on some crunchy crisps, that's sound. But what is it? Is it magic? Well, it's even cooler than magic because it's science. Sound is a super special kind of energy that our amazing ears can pick up. Sound is all about wiggles. Tiny, tiny movements that happen super fast. These wiggles are called vibrations. Anything that makes a sound is vibrating. Think about a guitar. When you pluck a guitar string, you see it blurring, right? That fuzziness is the string vibrating. And guess what? As it vibrates, it makes a sound. Twang! Even your own voice works this way. Inside your throat, you have something called vocal cords. When you talk or sing, your vocal cords vibrate, creating all the words and tunes. From the gentle rustle of leaves in the park to the loud cheer at a football match, it all starts with something somewhere, doing a little wiggle dance. Every sound has a source, and that source is always vibrating. So next time you hear a noise, try to imagine what tiny thing is wiggling to make that sound reach your ears. It's a universe of wiggles out there. Alright, science explorers, we know that sounds are made by vibrations, those super speedy wiggles. But how do those wiggles get from, say, a ringing telephone all the way across the room to your ears? Sound needs a helper to travel. It needs something to pass the wiggles along, like a game of pass the parcel, but with energy. This something is called a medium. A medium can be a gas, a liquid, or a solid. Without a medium, sound can't travel. The air all around us is a gas. When something vibrates, like a buzzing bee's wings, it bumps into the air molecules next to it. Those air molecules start to wiggle, and then they bump into their neighbors, and so on. This chain reaction of wiggling air molecules is what we call a sound wave. Now, what about liquids? Does sound travel through water? You bet it does. And it travels even better and faster through water than through air. Imagine you're swimming in a pool, and someone clicks two stones together underwater. You'd hear it really clearly, wouldn't you? That's because the molecules in a liquid are packed closer together than in a gas. Whales and dolphins use this to their advantage. They make clicking and whistling sounds that can travel for many, many miles under the ocean, helping them talk to each other. And finally, solids. Sound can travel through solid things too, like wood, metal, or even the ground. Remember the string telephone experiment from when you were little? You talk into one paper cup, and your friend can hear you through the other cup, even if the string is quite long. Try putting your ear against a closed door while someone knocks gently on the other side. The sound travels right through the solid wood. Science is solid. Okay team, let's tune into another amazing aspect of sound pitch. Not all sounds are the same, are they? Some sounds are really high, like a tiny mouse squeaking eek, or the piercing whistle of a referee at a sports game. Then there are other sounds that are really low and deep, like the rumble of a big lorry driving past, or the moo of a cow in a field. This quality of a sound being high or low is what scientists call pitch. A small squeaky whistle produces a high-pitched sound. A big booming foghorn produces a low-pitched sound. Our ears are brilliant at telling the difference between all these various pitches, helping us understand the world. So, what makes a sound high-pitched or low-pitched? It's all down to how fast those vibrations are happening. If something vibrates very, very quickly, lots of wiggles per second, it creates a high-pitched sound. Imagine a tiny short guitar string. When you pluck it, it wiggles incredibly fast, and you hear a high note. On the other hand, if something vibrates slowly, fewer wiggles per second, it creates a low-pitched sound. Think of a big, long, thick string on a double bass. When a musician plucks or bows that string, it vibrates much more slowly than the tiny guitar string. So, fast wiggles mean high pitch, and slow wiggles mean low pitch. It's a simple rule, but it explains so much about the music and noises that fill our lives. It's a fundamental principle of sound science. Exploring sound strength and speed. Loud sounds have high amplitude, quiet sounds have low amplitude. Amplitude is the energy of the sound wave. Like ripples from a stone in water. Big stone, big ripples, small stone, small ripples. Frequency is how often vibrations occur. High frequency means high pitch, low frequency means low pitch. Our ears hear a range of frequencies. Amplitude is loudness, frequency is pitch. Section 5. Be a sound scientist. Fun experiments and everyday wonders. Are you ready to become a sound scientist? Let's do some experiments. First, find a rubber band. Carefully stretch it between your fingers, but not too tight. Now pluck it with your other hand. Boing! Can you see it wiggling? That's the vibration. Can you hear the sound it makes? Try stretching the rubber band tighter and plucking it again. Does the sound change? It probably gets higher pitched. That's because a tighter band vibrates faster. Now try a thicker rubber band. Does it sound different to a thin one? You're exploring pitch and vibration right there in your hands. Science is hands-on. Here's another classic. The coat hanger gong. Ask a grown-up for a metal coat hanger and 2 pieces of string, each about as long as your arm. Tie 1 piece of string to each end of the coat hanger's bottom bar. Now wrap the other end of each string around your index fingers. Gently put your fingers in your ears, letting the coat hanger dangle down and swing. Carefully let it bump against a table or a door. Wow. You should hear an amazing, deep, gong-like sound traveling up the strings right into your ears. The metal hanger vibrates and the sound travels super well through the solid strings. Sound is all around us in so many everyday things. Listen to the birds singing in the morning. They make high-pitched chirps by forcing air through a special organ called a syrinx, making membranes vibrate very quickly. When you pop bubble wrap, the sudden rush of air creates a sharp sound with a quick, strong vibration. Even the fizzing of a fizzy drink is sound. Tiny bubbles of gas bursting create tiny vibrations in the liquid and the air. Your own tummy rumbling is the sound of gases and liquids moving around inside you, causing vibrations you can often hear and even feel. So, you see, sound is an incredible part of our world, and it's all based on simple science vibrations. From the highest whistle to the lowest rumble, from the loudest crash to the softest whisper, it all starts with a wiggle. I encourage you to keep your ears open. Listen carefully to all the different sounds you hear today. Try to think about what might be vibrating to make them, whether they are high or low pitch, loud or soft. There's a whole symphony of science happening around you all the time. Keep exploring, keep questioning, and keep listening. Science is everywhere,